Good morning and welcome to the video on how to do the review for the quiz next week. Just these first two problems here, I'm only going to do one of them, but basically when you want to graph an exponential function, we just advise using a t-table. So what I would do is I would just draw a little t-table like this. I'm just going to do number 2 here. And you would just plug in points, and typically we want you to plug in like -2, -1, 0, 1, 2. So if I plug -2 in, I would get 4 times 3 to the -2 power, which remember is 4 times 3 over 1 to the -2. If you flip that, that's 1 over 3 to the +2. Remember that negative exponent will flip things, and so that becomes 4 times 1/9, because this would become 1/9, and you would end up with 4/9 for that. By the way, don't be surprised to see a lot of fractions. When you plug in -1, same problem. This time I'll put a -1 right here, and what happens is I would end up with -1. I would flip it, it would become +1, so that'd be 1/3, so this would be 4/3. When I plug in a 0, anything to the 0's power is 1, so it would just be 4 times 1, which is 4. When I plug in 1, I would get 4 times 3 to the 1, which is basically just 4 times 3, which is 12. And by that time I'm already off the graph, so I don't even need to plug in 2. So if I go to -2 and go 4/9, I'd have a dot right about here. That's this one. And then at -1 4/3, that'd be right about here. That's this one. 0, 4, 1, 2, 3, 4 would be right there. And then 112, of course, is way off the graph somewhere. Because we know exponentials always go like this. They come flat and then they skyrocket like this. So this, oops, let me redraw that. So basically you would get a very steeply rising graph, okay? Sorry about how bad that is. I'm trying to do this on a tablet, and every time I touch stuff with my hand it goofs things up. Okay, so that would be that one. Remember that the x-axis is an asymptote, so it will never cross that x-axis on these first two. Also remember, if the number inside here was less than 1, like if this was 1.5 to the 1/2 times x, it would actually do decay instead of growth. So before you ever do a graph, you should look at this number right here to decide if it's going to go up or if it's going to go down. Okay? That's growth and decay. All right, these next few problems, it says tell whether each is growth or decay. Well, basically this is the number you look at. So this would be decay because that number is less than 1. This is the number you look at, so this would be growth because it's bigger than 1. And this one is really 5 times 1/4 to the x power. So this is actually decay, even though it kind of looks like growth because of that negative exponent. Okay, the next part here is writing an exponential whose graph passes through the given points. Now for these two, all you need to do is use y equals ab to the x power. That's your standard equation for an exponential function. And you take these 2 points, this is x, this is y, this is x, and this is y. And so basically you take 2 and you plug it in for y, so you put your 2 here. Your 0 goes in for x right there, so you get a times b to the 0 power. All I'm doing is plugging in x and y. And I end up with 2 equals a times anything to the 0 power is 1. So that's really just a equals 2. So I found my a. Now I go to the second equation, And again, I plug in 10 for y, 1 for x, and this time I actually plug the 2 in for the a. So I get 10 equals 2 times b to the 1 power. And this time I'm trying to find b, of course. So I would go 10 equals 2 times b, divide by 2, and b would be 5. Now I have my a, I have my b, so the exponential function would be y equals abx, which is 2 times 5 to the x power. So basically, whenever you're trying to write an exponential function and you're given 2 points, you plug the points into the standard form, you plug in your x and y, and you solve from there. Now, these two are this one's kind of easy because one of them was a 0. Later on, I think in one of the problems, I'll show you how to do this where it's not a 0. Okay? Once you find your a and your b, you pop those numbers into the standard form again, and you have your equation. You should always have an x and a y in your equation. So where the x and y are, you just put the x and y back in there. Okay, these next few problems, basically all you're going to do is follow your normal exponent rules. So when I multiply two things together, I always add the exponent. So if I did x to the second times x to the third, that would be x to the fifth because I add them. So this would be likewise y to the root 6 plus 5 root 6. See, I'm adding my exponents just like I did here. And this is like 1 root 6. So 1 root 6 plus 5 root 6 would be y to the 6 root 6. And there you have it. Okay. This one is a power to a power. So number 10, if you think of like a basic one, if I had n to the third to the fifth, that would be n to the 15th. Well, same thing here. You would multiply your exponents. So you would do n to the root 3 times root 75, which is n to the root 225, which is n to the 15th. I'm just going to double check that on the calculator really quick, but I'm 99% sure that 3 times 75 is 225, and it is. Good. Okay, so that one we'll clean up into this. And then finally, same thing, multiply. So you would go 2 to the root 2 times root 8, which is 2 to the root 16, which is 2 to the 4th, which is 2 times 2 times 2 times 2. So obviously that would be what? 16, I guess. Okay, so that's all you'd end up with on that one. Just double checking that and we're good. Okay, moving on to the next section. Solve each equation and inequality. Check your solution. So on these, the key is to get the same number as your base on both sides. So number 12, for example, I would do 3 to the 3x minus 5 is greater than 3 to the 4th power. So you have to think of how can I make 81 into 3 to some power. Once you have the bases to be the same, you can pretty much get rid of the bases and just take the exponents now and say, well, the only way this is going to be true is if this guy's exponent is bigger than that guy's. So 3x minus 5 must be greater than 4. And then you can solve that. So you add 5 to both sides. So 3x is greater than 9, and then you divide by 3, and you would get x is greater than 3. So x would be greater than 3 is the solution to that one. Okay? Let's go to 13. 13, we already have the same base on both sides, so this is actually a real easy one. All we do is we just cancel out the bases and set the exponents equal at this point. Once your bases are the same, you can just set your exponents equal. So you can do this. You can subtract 2x from both sides. You get 4x equals negative 20. Divide by 4. And x would equal negative 5, I believe. Okay? So that would be the answer to that one. Number 16 is a very difficult one because, let me see, 16 squared is not 128. Now, on one like this, where you can't turn a 128 into a 16, you could knock both of them down to a base even smaller. For example, 16 is 2 to the 4th, to the 4n minus 1, and 128 is 2 to the 7th power. Sometimes you need a calculator to help you figure that out, to the 2n plus 1. So now I have a base of 2 on both sides, but you see how I did that? You always have to be thinking of how can I get the base to be the same on both sides. Now, how do you do this? You do a power to a power. So you would do multiply. So this is 2 to the 16n minus 4. I'm just multiplying 4 by that. And multiply this and get 2 to the 14n plus 7 power. Now we can just get rid of those bases. So 16n minus 4 is equal to 14n plus 7. I subtract 14n from both sides, and I get 2n. I add 4 equals 11, so n would be 11 over 2. Okay? Now you can see that's quite a mess when you get all done with it, but that's really the only way to do that, is to just gradually work through it. Okay. Moving on to number 14. This one, I'm actually going to erase what I already have here, so I got a little room again, sorry. And I'm not a professional video maker, obviously. When you got a 9 and a 27, again, you cannot make a 27 into 9 to a power, so we're going to have to go to a smaller power. So 9 is 3 to the 2nd, to the 2x minus 1. And 27 is 3 to the 3rd, to the x plus 4. This one's very similar to number 16 we did. So now you multiply, so you would get 3, multiply those together and get 4x minus 2. Again, multiply, so you would get 3 to the 3x plus 12. The bases are now insignificant, so we can just say 4x minus 2 is equal to 3x plus 12, and then we just finish this off. So we would subtract 3x, you get x, add 2, and you get 14. So your final answer should be x equals 14. All right, and then the very final one is 15. This is probably the toughest one of all, and again, I need to make some space for this one. So I will do this one right next to here. Basically what I'm going to do is I start out with this. I need to turn that 8 into something with a 2. So I'm going to go 2 to the 3n minus 1. I really didn't do anything to that side yet. Equals, that was greater than or equal to, 1 over, how could we rewrite 8? Well, that's 2 to the 3rd power. So we would do this. Now you may go, well, you got the 8 to be a 2, but you still don't have it on top. So what we can do now is we can use our exponent rules, and we can flip this. So this would become 2 to the negative 3, which is the same thing as 1 over 2 to the positive 3. There's one of my exponent rules. Then I would multiply, so I would get 2 to the 3n minus 1 is greater than or equal to 2 to the negative 3n. And now I can just ignore the bases. So 3n minus 1 is greater than or equal to negative 3n. I would just, probably the easiest thing is to move this negative well, I could subtract